For lab 5, I chose to use Newton's second law to analyze an object decreasing with a constant velocity, my GPA, which will be modeled by a stress ball. The equations I'm going to use in this lab are V final equals V initial plus F net over M times delta T, and final position equals initial position plus V average times delta T. And Newton's second law pretty much says that an object moving with a constant velocity will keep going unless a force acts on it. So this is our model itself, the ball moving the negative x-axis with a constant velocity. Boom. Next we go to Python, where we plug in our givens, the mass of the ball using the model my GPA, the initial position and velocity in the video. Then we put in the time the ball moves for open 7 seconds in the interval. F net equals 0 because we're modeling constant velocity with a 0 net force. And we have the equations for Newton's second laws here. So when we run the model, it gives us a nice downward sloping graph for my GPA slowly decreasing, and the ball moving in the negative x-axis direction. And finally, I compared the points from the Python model and the Python computational model and the actual one. And the points are pretty similar, except for at the beginning, because Python does not account for the friction force which happens in real life. And that's my GPA slowly going to 0. Have fun, guys. And yeah, the lines are straight, so that indicates constant velocity if there's a 0 in that force.